Hello. In the previous lectures, we talked about the input-output systems of a system of a computer, right? And before that, we had gone through the microarchitecture, that is how we implement a processor. And before that, we had gone through the instructions architecture, that is the architecture of a processor. Now we move forward and we take a look at the memory systems. Memory systems include main memory, cache memory, and a concept known as virtual memory. So first we will begin with the concept of memory hierarchy. Okay. So memory hierarchy basically is related to which type of memory is closer to the processor and which type of memory is accessed more. Okay. So first of all, cache memory is something that is considered to be in the chip of the processor, right? When we buy a processor chip, whether it is i7 or i5 or whatever, they will be saying that okay, this has this many MBs of level 1 L1 cache and this many MBs of L2 cache and something like that. So these cache memory is something that is coming within the processor chip. Okay, it is coming along with the processor. Then we have what is the main memory. This is not on the processor chip, this is outside of the chip. Then there is the hard disk. Okay, so this is how the relation comes. So the CPU initially, for whatever the requirement is, whether it is a data or instruction or whatever, it initially looks in the cache. Okay, if it doesn't find it in the cache, it will look for it in the main memory. If it doesn't have it in the main memory, then only it looks for it in the hard disk. Okay, so consequently the cache is the most frequently accessed memory. It is very fast. So when we consider the hierarchy, not only it is regarding the proximity to the processor, but also it is regarding the speed or the time required to access a memory, right? So this is a typical memory hierarchy pyramid that we use to show the hierarchy. So on top is the cache memory, right? Cache memory, it is the fastest. So as we go up, the speed increases, and as we go down, the capacity increases. So cache memory, it is the fastest memory, and it is also the smallest memory, and it is very costly. So the access time is approximately 1 nanosecond, and it is very costly. Okay, and these are some old figures in 2006, but the actual figures may change, but the relative cost, time and capacity are pretty much similar. It doesn't change that much. So the takeaway should be that cache is the smallest memory, yet it is the fastest memory. Also, it is very costly to implement. Okay, then coming to the main memory. So main memory, till now, whenever we were discussing about whether it is IO systems or the microarchitecture part, we didn't make a distinction between cache and main memory. We just said memory, right? So now we are actually making a distinction. That is only difference. So main memory means which is something memory that holds the data temporarily. Cache also holds the data temporarily. But the thing is that main memory has a higher capacity, but it is slower. Usually when we talk of main memory, we consider RAM only, random access memory. We will go through the details of these different types of memory later. First we will have a general understanding and an outline. Okay, when we talk about main memory, even here the technology they are given is DRAM, that is dynamic RAM. But the thing is that many times, not many times, in all computing systems, there will be type of memory known as ROM, read only memory, which also is considered as a main memory, right? We'll come to the details of that later. Then the last, the bottom part, it is virtual memory, or you can say secondary memory, which is the hard disk. Okay, so this virtual memory, or you can write secondary memory. There isn't much of a practical difference. So this is a memory hierarchy. We have the cache memory, main memory, virtual memory, or secondary memory. Okay, so the implementation is used here is hard disk. For main memory, it is dynamic RAM or ROM. Okay, it can be ROM also. For cache, we are using static RAM, SRAM. Okay, so moving on. Now let's see how we can analyze the performance of a memory system. For that, we use certain terms. The first one being miss rate. Okay, first one being miss rate. The second one being hit rate, and the last one being average memory access time. So again, miss rate, hit rate, and average memory access time. So this is pretty much self-explanatory. Miss rate is number of misses by number of total memory access. So what is miss and hit? Right, what is miss and hit? So suppose the processor wants some data, or some data, let's say, suppose the processor wants some data. So first it will look in the cache. Okay, and it need not always look in the cache. The concept of cache is that cache stores data and instruction which are very frequently used. So sometimes the processor may directly check in the main memory, but usually it for as a rule of thumb, you can consider that first the processor checks in the cache. So when the processor is looking in a certain type of memory, and if it finds the required data there in that particular memory, it is called as a hit, right? If the processor looks for a certain information or data in a certain memory, and if it finds it there, it is called as a hit. If it doesn't find it, it is called as a miss. If the CPU is looking for a certain data, and if it searches in the cache, and if it is a hit, fine, the processor takes the data and moves on. If it is a miss, then what will it do? Then the processor will go to the main memory and search, right? So if it is a miss in the cache, then it will go to search the main memory. So if it is a hit in the main memory, fine, that is it. The processor will access the main memory. So if it is a hit here, then that is it. If it is a miss here, then it will go to the main memory and search. So what happens if it is a miss even in the main memory? Then it will have to look for it in the hard disk or virtual memory. Then it will have to take it and bring it to the main memory, right? So that is the hit and miss concept. So miss rate and hit rate, whenever we are defining it, we have to define it, or we have to calculate it for a certain type of memory, right? So miss rate will be there will be a certain miss rate. It will be there for cache memory. There will be a miss rate for main memory, like that. So miss rate and hit rate by itself, it need not have any value. We have to consider which particular data, which particular memory is being accessed. So let's consider an example. Suppose a program has 2000 data access instructions, loads and stores. Means it has to access data 2000 times for implementing a certain instruction, and 1250 of these requested data values are found in the cache. The other 750 data values are supplied to the processor by the main memory or hard or disk memory. What are the miss and hit rates for the cache, right? So when we are calculating the miss rate or hit rate for a certain type of memory, we are not bothered about from what type of memory we are getting the missed data, right? Here 750 data are taken from the main memory or disk memory. That means it doesn't matter. If it is not there in the cache memory, that is it. It doesn't matter whether the missing data is coming from the main memory or disk memory when we are calculating the hit rate and miss rate for a particular type of memory. So here miss rate is missing is 750 by 2000, so this much percentage. Hit rate is again either this or 1 minus this. Simple calculations. So the next one is the average memory access time, right? Average memory access time, that is on an average how much time does it take for the processor to access memory and get the required data or instruction. Let's say data, forget about instruction for the time being. That is average time required for the processor to access a data. So first, where will the processor look? It will look at in the cache, right? So time for accessing cache, it is there. T cache is the time, access time of the cache. If it is not there, right, what is the condition that the value or the data we need is not there in the cache? It means there is a miss. So then we have to consider the miss rate of the cache. MR is miss rate and miss rate for the cache, right? So T cache, time of accessing the cache, anyway it will access the cache. If it is not there, that is if there is a miss, then what happens? It will search in the main memory. But when we are taking the average, on average the cache has this many this amount of miss rate, right? MR cache. So we have to multiply this TMM, that is the time for accessing main memory, with the miss rate of cache. So if this data is not there in the main memory, what the processor has to do? It has to look in the virtual memory. So that is the time for accessing the virtual memory. Again, we here if it is not there in that cache memory, whatever time value is coming after that, we multiplied with the miss rate of cache, right? Miss rate of cache. Similarly, if it is not there in the main memory, whatever value is coming after that, we have to multiply it with the miss rate of the main memory. So if it is a time for accessing the cache plus miss rate of, right, miss rate of cache into whatever comes after that. So what comes after that? It could be there in the main memory, that is time for access in the main memory. If it is not there, then that is if there is a miss, then miss rate of main memory into time for access in the virtual memory. And what if it is not there in the virtual memory? Then we have an issue that the data, some error will be thrown. So this is the formula. Average memory access time is T cache plus miss rate of cache into time of main memory plus miss rate of main memory into time of virtual memory. So let's see an example here for calculating the average memory access time. Suppose a computer system has a memory organization with only two levels of hierarchy, that is a cache and main memory. We are not considering virtual memory. So what is the average memory access time given the access times and miss rates given in the table 8.1, this one, right? So for cache, the access time is 1 cycle and the miss rate is 10%. That is for every 10 searches, 1 will be a miss and 9 will be a hit, right? And main memory cycle access time is 100 cycles, but the miss rate is 0. What does it mean? What does it mean that a miss rate is 0? It means anything that the processor needs, any data that the processor needs, it will be there in the main memory, right? So if it is not there in the cache memory, it will definitely be there in the main memory. So what is the average memory access time? T cache, that is 1 T cache plus miss rate of cache MR cache into TMM. If there was a virtual memory, what would have been then? It will be TMM plus miss rate of main memory into TVR, VM, something like that. But for the time being, it is T cache plus miss rate MR cache into TMM. That is 11 cycles. Okay. Now that we have had an overview about memory systems or memory in general, its hierarchy and its performance parameters, now we will move on and have a look at memory, how memory is built, different types of memory, and how we are using the memory. We will have a look at it in detail, and that we will do in the next lecture. Thank you.